we've already seen a little bit about bits and bytes, but how do we use that information? Well, first of all, why do we care? Why do we care about the file size in bits or bytes for files on a website? Why is file size so important for a website? Well, there are three main reasons: to reduce download times, to reduce the amount of network traffic, and to reduce the storage required on a web server. We reduce the download times because the user experience will be better and the user will be happier if the page loads quickly. We also want to reduce the amount of network traffic. This is the amount of bytes that you're sending from your server, also called data transfer. And you might hear if you've got a 5 gigabyte mobile plan or a 100 gigabyte home internet plan. It's the amount of bytes that you can send per month. Sending and receiving data over the internet costs money. And it costs money for the server who is hosting a web service, for example, and also for the client, the user who's visiting it, will often have a data limit. And this is also called data transfer. So we want to reduce the amount of network traffic on our site. And finally, we also want the file size to be small to reduce the storage that we need on our web server. If the files are very, very large, file storage costs money. It costs money for the hard drives, for example, and to put files onto the server. So we want the files to be small if we can. And one way to make them small is compression. This is a great way to make fast websites. And we can compress pictures and audio and other things, and compression reduces file sizes. Uncompressed files can be very, very big. We have, in this zone here, we've got uncompressed images, like a bitmap, for example. And over here, we've got uncompressed audio, which is a WAV file. These are very, very big files, but all of the quality is preserved perfectly with them. But they're very, very big, and we want to have smaller file sizes. So we also have compressed file types. For example, these two different types of compressions, by the way. We've got lossless compression and lossy compression. In lossless compression, and I'll show you some examples later, so it's not perfect. You might lose some detail, but at least the file sizes... I've got that the wrong way around, haven't I? Lossy compression. There we go. Lossy compression is not perfect. Lossy compression, some detail might be lost. So for example, JPEG is lossy. GIF is another image format that is lossy. We can store audio in MP3, which is lossy. These all make a really small file, but you lose some quality. It's not perfect. You might lose a little bit of detail. And maybe most humans won't even notice. Maybe all humans won't even notice the detail that's lost. But it's not perfect. So you get a tiny file, but it's not perfectly the same. So we also have lossless compression. And lossless compression saves the original perfectly. Kind of like a zip file saves the original perfectly. A zip file is an example of lossless compression. So for example, we've got PNG is a lossless, one form of lossless compression for images. And for audio, a FLAC file is common for people that demand the very highest audio quality because it is lossless. You keep the original perfectly. Let's see what that looks like, the lossy versus lossless. I have some examples here of the same photo I've taken, and some are compressed. Actually, they're all compressed. But which do you think are lossy and which are lossless? Can you tell the difference? Well, this here is a JPEG. It's lossy, and it's 90 kilobytes. This is a JPEG that I saved on higher settings, and it is about half a megabyte, 433 kilobytes. And this one is a PNG. So this is still compressed, but it is compressed with lossless compression, so it preserves the original perfectly. Let's zoom in. Even when zooming in, can you even tell the difference between lossless compression and a good quality lossy compression? Maybe not. So it's often worth having the really tiny file size that comes with being compressed, with lossy compression, instead of a small but pretty big still file size with lossless compression. So JPEG is lossy compression, and PNG is lossless. It's a perfect copy of the original, but smaller in file size. To summarize, compression is encoding the same information using fewer bits than the original representation. So for example, here we've made the image take up less space on the disk. Lossy compression is not perfect. You might lose some detail, and the file size is usually really, really tiny. Whereas lossless compression saves the original image perfectly, still makes the file smaller while saving the original perfectly, and the file size is reasonable. To compare, if we didn't have compression with something like a bitmap, this would be 15 megabytes, so almost triple the size of this one. So we could send the original without any compression, but the file size is huge. And why wouldn't we just use the lossless one? It's the same quality, but just the file size is smaller. Some more differences between PNG and JPEG. JPEG is really bad at sharp edges, so text or things with solid areas of the same color, like illustrations. There we go, webcomics, logos. And JPEG often has compression artifacts, and artifacts are where you can notice the lower quality. Notice here that's compression artifacts around the text. You can notice the lower quality. As an added bonus of PNG, PNG does support transparency, whereas JPEG does not support transparency. And we can see a transparent logo on the internet. I've prepared a little video here. This is the Pulteney logo, and it comes from this image here. And because it is saved as a PNG, it works on any background. You can change the background color to work on any other background. Whereas if it was a JPEG, you wouldn't be able to save it with a transparent background like this. You would have to pick a color for the background. So if you need a transparent background, then PNG is good for that. JPEG can't do that. So now let's think about which format you think would be appropriate for these 4 situations. A selfie to display on Facebook, a raw audio file for editing, a logo that needs transparency, and a song that's in Spotify. For a selfie to display on Facebook, I would do a JPEG because compression artifacts aren't very obvious on photographs. They're more obvious on logos and things like that have sharp edges and solid colors. And also speed is very, very important on a website. And we've seen a JPEG can be really, really small. A raw audio file for editing has to be WAV or FLAC, I would say, because it perfectly keeps the original audio. You wouldn't want a lossy format like MP3 because then you would lose quality as you're working on it, or at least before you finish it. A logo that needs transparency. There are only 2 of these formats that have transparency. We've seen PNG supports transparency and also has good support for sharp contrasts, like the edges of this logo, the solid colors, and they would cause compression artifacts in JPEG. GIF would also be a good choice for the same reasons. And finally, a song that's embedded into the Spotify web app. While you're serving it over the web, you probably want an MP3 because it will significantly reduce the file size and the download time because of its lossy compression. I will say though, some people might prefer FLAC if they want really, really high quality audio. So if people are obsessed with audio quality, they might prefer FLAC. And that is the end. Beautiful. I hope you've learned something about compression. Bye everyone.